Good afternoon. My name is Ezz Tahoun, and today we're going to walk through our presentation for the Blackhat Attack Flow Detector. I'm definitely going to borrow some of the slides I used for my Blackhat keynote, but essentially we're going to focus most of this on actually seeing the tool working instead of on slides. I'm a cyber data scientist. I'm very focused on utilizing the best on AI and machine learning into our cybersecurity problems. There's a big problem in cybersecurity, essentially focused on figuring out which of the multiple alerts that we get every day are actually relevant to each other. And we usually call that problem contextualization problem or correlation problem. And that is mainly what we're going to focus on today. So this idea of contextualizing events and essentially, ideally, getting some sort of a kill chain out of them. So if we review a little bit about what we have so far, ideally, we already have an aggregation of alerts and events into one place. That usually is like some sort of a database or some sort of a SIM, and that is where you get a lot of your events, and you would have some queries, and these queries could be like detection queries, like Sigma and Yara, or could be some sort of correlation or contextualization queries that you've developed. These could also be like some sort of playbooks, and these playbooks could be like in your SOAR or in some sort of threat intelligence enrichment or whatnot. But essentially, ideally, you would have some sort of mapping to a cyber adversary intent, such as the intent that could be mapped to like a micro-attack technique. So if we look at an event, ideally I have some sort of micro-attack technique. Why? Now that I have this, I have so much metadata about this alert. So if I have an alert, I have a micro-attack technique for it. Somehow, now I have like detection methodologies, mitigation methodologies for my junior analysts. I might have procedural examples, yada. And then the second part is ideally, once I have that event, I can correlate it to other events that show a progressing sequence of the intent of the adversary. So I can tell that the adversary, okay, they already did their phishing, they already did their initial access. Now I'm seeing not just an initial access or phishing alert. No. Now I'm seeing an alert for execution on a relevant relevant machine to that first alert. And then I'm seeing some sort of I'm seeing some credential access again. Relevant to that business unit that got affected, or relevant to that persona that got affected, or relevant to the organization, or relevant to the technical infrastructure, such as relevant in terms of like same OS, same port, same software, same business unit, same person, but a different machine that they're using. So much could be captured in relevancy, but ideally that's the idea. So the idea is I get some sort of micro-attack technique for every alert, and that helps me with my enrichment, and then I get. The end goal is essentially not just contextualization, but ideally show me the actual application, right? And that is a very big goal. And ideally, essentially that happens on heterogeneous data. Because as we said, we have so much data, right? So we have so much data. If I just do this on antivirus logs, I mean, sure, but you didn't take into account my email security, you didn't take into account anything else, like network, cloud, identity. And essentially, we take a look at how we could do this. So we say, again, first step, get me techniques. Second step is essentially get me code relevant events. So we essentially have a detector model that we will play with today. And we essentially also have what we call a clustering model, as well as it doesn't just do clustering, but also does sequentiality. So a little bit about how that would look like. We essentially look at all of the possible relevancies together, and then we sequence them. And that is also a model that we will delve into today. So essentially back to back, they look something like this. You send them all of the alerts, and they would essentially get you out of it a bunch of clusters and a bunch of attack flows, or a bunch of attack sequences, or a bunch of micro-attack flows, or you can call them kill chains, attack scenarios. They have a million names. But essentially the idea is you get techniques, you cluster, and you correlate for sequentiality. And the input usually looks something along these lines. And then your output is essentially this aggregated and now has techniques, and then this clustered, as you can see, and then this is kind of in a flow, very low resolution. So how do we differ from today's rules? Like, can't I just get some of these rules on my Splunk, on my Elastic, on my SecureNX, XRD, whatever it is? Why is it so hard to get these? Like, AI is everywhere today, so I'm not sure what am I getting here today? Like, what is really the idea? Well, there's something called pairwise operations. Pairwise operations means that you're running queries that are extremely expensive because they're not efficient. They are comparing one alert to another, such as, for this alert, why don't you contextualize it? This alert affected Ezz. So can we compare this alert to this other alert that also affected Ezz and see how are they sequential to each other? Can we compare what is relevant between them? Or maybe even better, you know what? We don't actually do a pairwise comparison. We just get me everything that is relevant that has affected Ezz in the past 7 days. But why not 8? Why not 9? Why not 10? Why not 11? So in queries, they're very, very focused. They're very, very narrow. So they're good for detections. It's iffy how useful they are in correlation and contextualization. And hence, today, when we look at Fortune 100 companies, Fortune 200 companies, big customers of Splunk, and big customers of SIM, people that spend a lot of money customizing these kind of solutions, they actually don't use them as much. They're just very, very expensive. Like you pay Splunk for every query, you're paying Splunk for every compute in your license. And then you're also paying your actual compute infrastructure for all of it. So if you're constantly running these, it becomes very, very expensive. So you start thinking, oh, when should I run this? Oh, let me be very selective when should I run this. And hence, these rules do not really do contextualization as they should, or they don't really do correlation as they should. And then the second part is they're impossible to adapt and maintain. So you spend pretty much like 5 FTEs every year to maintain and tune these rules. Like you change something in your infrastructure, you change your antivirus, you change something, you need to redo all of the rules. Business units, new leadership comes in, changes something here, changes something there, there's new enrichment, we got like a new threat intelligence provider, whatever it is, you have to redo all of your contextualization and correlation rules. And then when they work, you're essentially looking for very, very specific, narrow attacks that you're correlating. Like for instance, in analytical stories, like you're really focused on this sequence. If this sequence changes a bit, you're out of luck. And they're also focused on very, very narrow stuff that they miss all the nuances. So like what? Like port 80 and port 443. If you're just filtering on 80 and 443, looking for web traffic, how about 8443? How about 8080? How about 81? There are so many other ports. Now you have to actually put these, now that we know that there are alternative ports, you have to ask your engineering team to put that in all of the rules. Okay, so how about the nuance of certain techniques being similar in mind? How about the nuance of two business units being similar? All of these have to be manually put into rules, and hence very, very hard to look for new attacks. If the attack changes a bit, you're missing. And then the other piece is these rules are usually not standalone, so ideally here we make a solution that's completely standalone and can play with everybody. Play with all of the SIMs, all the SORs, all the TIPs, whatever it is, all the XDRs, all the MDRs, insert whatever abbreviation you want. So anyways, let's take a look at how that would happen. So the idea here is essentially you have what you already have in your SIM, and that SIM is already collecting so many alerts, as you can see from the figure on the left, like just alerts. And some of these alerts are colored red with X's, and these are kind of part of a coordinated attack. The rest are just like lone incidents or false positives. So how do we find these little ones that are actually traces of a coordinated attack? Ideally, we have essentially a way to pull them out and find these relationships between them. Now we're able to say, oh, you know what? These 4 actually have relations between them, and hence they're part of something together. We will figure out what this something is, but for now, they're relevant to each other. If you can capture relevancy, now these 4, you're not dealing with them in a siloed fashion, you're saying these 4 are actually together. Or these little red dots in the figure here, in this figure, right here, these little red things floating around, these little alerts, they're actually part of something together. We find the relevance. And that's how we do it here in this figure with a little bit of essentially clustering magic. Once we find that, we find these relevancies, we're able to be like, you know what? Are they actually part of a kill chain? So now we have a cluster. Are they actually part of a kill chain? And if they are, good. Show it to me. Show me that kill chain, and let me actually take actions on. So that's essentially the idea. And I don't think there is much here that we should borrow. So I'm gonna kill this real quick, and we're gonna go into an actual, essentially demo. And before I start, to see that tool and to try it for yourself, you can just go to like AWS Marketplace or any of the cloud marketplaces and type in Cypienta. You will find the tools. They run on your own infrastructure, so no biggie. But to quickly give you an idea of input and output, this, for instance, is an input. And in this input, it's very, very expandable. So the format is very, very expandable. You can see here there are other attributes dictionary that is empty. But if I want, I can make whatever I want. So I can be like department, and then in the department I can be like HR, right? I can be like, okay, here's the port affected. So port, the port affected is 80, right? And then I can be like, okay, functionality of asset, and the functionality of asset would be whatever it is, right? Something. like SAP or whatever, right? And that's just an expandable format for me. But essentially, my main format or my main required pieces of the JSON that I'm giving to these models is simply an alert ID, the timestamp, whatever asset or assets are involved. So that could be just one or two. They don't have to be IPs. It could be host names. It could be whatever it is. Whatever node or identity or whatever it is that you want to put. And it could be the same for both. If it's just like one identity that did something like a login, a weird login, abnormal login, whatever it is. And then you also would have some sort of a message, right? Or some sort of the alert. And the alert would have a description, by the way. So the alert is never really the short. You can have like a description for the alert, and then you can really expand on the description for the alert, right? Like in this case, I think it's emerging threats at Cypienta, which is one of the noisiest, which is why it makes for a good demo here. But essentially, it's important to note that this is expandable. And now we would essentially feed this expandable JSON into our model. And how did we set up our model? So let's take a look. So our models currently are sitting in Amazon SageMaker. So if I go to my Amazon SageMaker and I take a look here at models, I can see my models. So here I can see, for instance, the endpoint. I have a real-time endpoint for the technique classification, and then I have a batch transform job created for every time I actually want to use my my correlation model, right? So I have all of the good stuff that I need in terms of essentially figuring out when to use both, and I have my code that tells me when do I use both. So in my lambdas, I can see here in my lambdas I have a bunch of them. So essentially I have a lambda setup, for instance, to create flow. I have a lambda setup for create whatever, and I have another lambda for process flow. And I can open all of these lambdas and see what's really going on in them, and this is all open source. So once you go, you find all of that code. But essentially I can explain a little bit, like here, like there's a trigger for S3 whenever someone uploads something into this specific S3 bucket called the attack detector bucket under the folder input. As long as it's a JSON, this lambda will trigger. And now what is this lambda going to do? Well, this lambda is going to do a bunch of stuff, including essentially chunking the files and essentially running this enrich alerts techniques. So it will take all of these alerts, assign techniques, this is the first model, and then it will do what? It will aggregate, cluster, and sequence alerts using the second model. So first, enrich alerts with techniques. Second, aggregate, cluster, sequence alerts. And of course, there are configurations assigned to all of these. There are different environment variables that the user can set. So this is as open as it can be. Like the chunk size, like what kind of folders, like classification output is where we find the technique classification. Response is where we find the flow model output. We can change those. And then the technique lookup, like there's something called the technique lookup, where I already know that this alert is this technique. I don't need to do it again. So like which models am I using? Well, you're using this for the technique. You're using this for the correlation. So it's very, very open source in a way that allows you to do whatever you want. And then there are other lambdas as well that would take the output of this and put it in the UI. So we also have an open source UI that would allow you to do that. But anyways, let's actually take a look at this bucket that we were talking about. So the bucket is called attack detector bucket. Let's quickly go to the attack detector bucket. And we can see in our input, essentially just JSONs. And these JSONs just look exactly like the JSONs we were just looking at here, right? So exactly the same idea of these JSONs, like just a bunch of, like so many, like tons of alerts from heterogeneous sources. So Cypienta Bro, CrowdStrike, Carbon Black, Palo Alto, whatever it is, right? All kinds of stuff. And then essentially we see that the model will create stuff under essentially classification output, which is actually what we get out of it, and that would be called input JSON. And we can actually see what is that. So what is input JSON? Well, input JSON is nothing but what you actually fed, but now it has techniques. That's the only thing. The only thing that actually happened here is we added techniques. That's it. We didn't change anything. We didn't change any of your attributes. We didn't change any of the stuff. All we did was got the model that you deployed on your own infrastructure. You never sent us any data. You had the container model that you subscribed to from AWS Marketplace deployed on your own stuff. You got techniques enriched in it, and that's about it. And now you have a JSON of that. If you remember, we were talking about this whole idea of lookup table. And that lookup table was saved under data in Lambda, and it was just updated recently. And we can see here how it looks. It looks exactly like this. Alerts and techniques. This is an alert that we saw before. This is the assigned technique. This is an alert that we saw before. This is an assigned technique. And now you can take this, give it to Splunk, give it to QRadar, Elastic, whatever it is. And now you have this lookup table for quick enrichment. You never have to do this again if you want. And you save compute costs. Like, I never have to actually invoke this model ever again. I never have to pay AWS or compute power or GPU power ever again. And by the way, there is absolutely no training here from scratch. Like we will get to the point where there is feedback very, very soon, but essentially there's no training. You just give feedback to the model. You're like, this is a bad technique. Here's the right technique. Or here's a bad cluster. Here's a better cluster. Here's a bad flow. Here's a better flow. And it would train based on your liking and execute on that. But anyways, so we take a look here for these clusters, and you can see that under response, if we click on any of these batches, we can see that these batches output essentially aggregated alerts, cluster, flow, and then essentially the whole thing combined in one JSON dot out. But how would a cluster look like? Well, a cluster would simply look something like this. Cluster ID, and then what aggregate alerts are actually part of this cluster, so in this case, a bunch of them. And then what is the earliest and what is the latest? What is this cluster start time and end time? And then here's some metadata for our next model, essentially just saying what count is within every aggregated alert, because we actually aggregate a bunch of them, as we mentioned. And now that they're aggregated, we kind of want to keep track of which is which. And then we actually have the average times, again, per the aggregate. So we have average times, and then we have all kinds of IPs or all kinds of sources, entities, identities, whatever it is, all kinds of destinations, all kinds of techniques per each as well, all kinds of tactics, all kinds of stages, all kinds of internal, essentially users, and so on and so forth. And then there are smaller clusters as well. There are tighter ones, and so on and so forth. And then the flow is essentially where you see these clusters paired in a flow that is actually sequential. So that is essentially the idea of this whole cluster and flow. And you can see them being outputted here. Now, we talked about other lambdas, and other lambdas simply don't do much other than just take these outputs and create them into essentially something that is easy to put on the UI. So we actually have a UI that can also be open source and easily put in your AWS infrastructure. And in this case, you would essentially have also an open source lambda, such as essentially this process flow. And this process flow essentially triggers on, again, the S3. This time around, it's triggering not on input anymore, but actually on the response. And now it takes this dot out and it splits it into a bunch, as we saw. And then we have one that says create campaign. So now that this dot out is split into these JSONs, create campaign will trigger again. And this time around, this lambda will actually create the UI. So once it has the output, you can see here in create campaign, the code again is open source, everything here is open source. It will actually go out there and actually create the campaign in the UI. And this is based on essentially what kind of UI is deployed. So in this case, we deployed an ACS, an Elastic Container Service, and we gave essentially a bunch of these configurations to environment variables such as the UI username, UI password, and the actual UI URL. Essentially, in this case, it's deployed in Canada Central on AWS. So let's go and find that. So let's go find this Canada Central ECS. Here we go at 8,000, and we can see here essentially there are a bunch of campaigns that we deployed here with our model data or our simulated data, our demo data, and we can see here right away it's in stages. So we can see that left to right we're looking at sequentiality, and then top to bottom we're going after time. So the timeline is top to bottom, left to right is going after sequentiality. And if I'm interested in essentially just taking a look at all of the events, I can, but I can see here that these events are tagged by tactics, or if I'm not interested in MITRE, I can go for stages. But I can essentially see a bunch of them are doing specific sequential stuff, and then I can also see the asset graph or the identity graph, and I can see, oh, you know what, like there are certain things here that are happening between specific machines that could be of interest to me or could be of use to me. And then I can actually pull the specific events if I'm interested, and this is where I can really give some feedback on certain techniques. So here I can be like, no, this is the correct technique, this is the other correct technique, these are wrong, or whatever it is, and I can give some comments to the model and I can submit that. Actually, right here, we can also do like some sort of IOC selection if we're interested in using the free UI for IOC selection, but essentially, if you don't do IOC selection, you only get your mitigation and detection advisories right here through technique. You also get some IOCs that are automatically extracted into the sticks viewer, and then you have sticks JSON that you can immediately download and utilize. You have a diamond model report with adversity infrastructure and essentially all kinds of stuff. Now, of course, the actual value of getting the stuff in the UI and actually using the UI is not really all the, I guess, the bells and whistles. Like, for instance, like exploring these cards, exploring these alerts or whatnot. But actually, the main value is, as we saw, like we can give feedback to the technique, but we can also give feedback right here. So we can copy and cut these events and put them into other clusters, put them into other campaigns, we can choose if we want to put our clusters and flows on the UI or just flows. For instance, in this case, we just put flows, but we can also give feedback to clusters, not just give feedback to the flows. And this feedback is essentially just let's remove some of these from the flow, or let's remove some of these from the cluster. Let's copy them from here to there. Let's cut some of them. Let's actually add to them. How about we add to them from a sim? How about we add to them from a CSV? How about we add to them from another campaign? How about we literally merge some of these campaigns? So really, the sky is the limit, and this is just the flows. So if we see here, we actually have clusters, and we can see that the sky is the limit really in terms of giving it feedback. So in this case, we have these clusters. Let me get a big one, maybe a big cluster. So nope, not this one. Let's get something that's really, really big. Let's see. So yeah, 300 events, 95 events. These are pretty sizable clusters here. Let's see what I have. Okay, so maybe this one is pretty big because you can see a lot of events here. A lot of assets are involved. So this is really, really big. Actually, you can see some of them actually don't have techniques. For instance, some of these don't have techniques at all. So you can actually see why don't we have techniques. In this case, they don't have techniques. It's EP policy, package management. It's very hard to put a technique in this one. So in this case, the model didn't. Or the settings of your Lambda or your team didn't want our model to give essentially a technique to this. And again, this is completely configured. So you can set up the thresholds you want. You can set up essentially which of them actually get a technique, which of them don't get a technique, which of them get put in a cluster, which attributes are more important in clustering. The whole thing is open. And in this case, we can see the UI helps us kind of visualize per timeline. So here we can see what timeline is involved for what. So if I scroll down, this is still in the first piece of the timeline. We can see here there's a lot of bells and whistles across. So you can see here, for instance, this is affecting only these two on the left here, these assets. And this is in the middle of the timeline. And I can be you know what, a bunch of these actually don't make a lot of sense to be put together. So let me just start marking them. And these actually don't make much sense to be put together. These are just DNS queries or something like that. And in this case, they're just affecting a bunch here. And I don't think this was good clustering. So I can go back and be you know what, you should hide complete. And the model would actually learn that. The model would be okay, that was bad. Let me actually learn that. And that learning is not shared with anybody else. Unless you really want to, that learning doesn't get sent to us automatically. You can configure it to be sent to us, but that learning does not get sent to us. Of course, when you start sending learnings to us, we start giving you learnings from other people kind of thing. But you can choose not to share any of that learning. So you can be you know what, I just want to set up my stuff in a way that would make sense. So let me actually mark these as stuff that I should copy here, cut here, and so on and so forth. And as we mentioned, you can start actually merging campaigns. So you can literally mark certain campaigns as they're supposed to be merged together kind of thing. And these are all things that you can work on. Here's a merge. Let me add campaigns from my SOR. Let me add campaigns from my whatever, and let me just put them on that free UI that I have that is local. But really, the main point of the UI is simply to give feedback to the models. And we saw essentially how these models are extremely, extremely easy to configure and monitor via CloudWatch. Logs from AWS, they're very, very easy, for instance, to actually track what are they doing at any given point. So for instance, these were the batch transforms that we put. So this was a batch transform that was run from this model. I can choose what instance, how much money do I actually want to pay, what instance is being used. I can see the output path for it. So this outputted right here in C31, this batch that I put, essentially what was the input for it. I can monitor it in real time via my logs. I can see the metrics for it. I can really change everything in the Lambda as much as I want. So very, very configurable and extremely open for your SOC team to adopt essentially a tool like this. And the code is very well commented. You can go in and just change different pieces. Essentially, the environment variable this is being read here as this, the environment variable this is being read as this. You can see the chunking, for instance, in batch. And these are working as batches, but they're also usable as real times. Right? And in this case, we're using one of the models in real time, the other one as batches. But this can go the other way around as well. And in this case, we're using S3, but you can have the exact same thing in Microsoft Azure, exact same thing in Oracle, exact same thing in Google Cloud. So really, there is no exclusivity here on AWS at all. And we would love to get your feedback. So please go to your marketplace on cloud and just look for Cypienta, and you would be able to start a free, essentially, evaluation of this technology that is completely open, and you can completely configure it the way you like. There are so many configurations, such as node, essentially similarity. based on the enterprise. You can say that these two nodes are being used by Ezz. This is like a cloud machine that is assigned to him, and this is like his laptop that is given out to him. These are the credentials that are assigned to Ezz. Like, you can really give a lot of these pieces, and you can be like, Ezz is working in our SOC, and so is Mark. And then you have like Mark and Ezz that share this attribute. Maybe Mark and Ezz share the same operating system for the laptop, and so on and so forth. So there's a lot of JSONs that you can give to the model to enrich what we call enterprise context or node similarity context, and that is helping the model cluster when it sees these events coming in and affecting these essentially nodes, which could be entities, identities, machines, and so on and so forth. Anyways, if you're interested in I guess getting some sort of open source exercises similar to maybe what we have usually on our blog, I encourage you to find our blog on cypienta.com. I think the blog is called cyberdatascience.org. You can always find it here in the resources tab, and you can find the open source cyber data science blog, and that is essentially where we post a lot of different exercises. And these are usually like 10-minute exercises, such as, for instance, like the insider threat one. So in this exercise, like if you're interested in doing some other essentially projects other than just like correlation or contextualization, in this one that you're detecting insider threat, we have all the code, we have data set, and this is like a 10-minute exercise for security analysts. So here's all the code in a well-commented Jupyter, and you can see here, for instance, what kind of data are we actually reading, is it a DLP or whatnot, and you can see the actual knowledge engineering. So we talk about knowledge engineering a lot. I was talking about it in a Blackhat keynote, so you can find the Blackhat keynote on YouTube. If you just look for Blackhat keynote Cypienta, it's 40 minutes of a presentation on essentially how we are not essentially using like a well-known, like, for instance, data-driven approach to build these models, but instead knowledge engineering for our correlation and contextualization, for instance. But essentially here, knowledge engineering or knowledge encoding could be like, for instance, like this is insider threat. So could data exfiltration happen in an EXE? Not very likely. So that would be a security analyst using that code and just like putting that piece. Security analysts could also be like, you know what, the context for timestamps here is, for instance, some of these are business hours, some of these are after hours, yada yada. And here context is very easy to put because it's simply just a bunch of rules or knowledge encoding rules. But there are so many of these examples that we essentially try to go through in our blog to really just get security analysts to be able to utilize essentially data science out there. If you have any questions or feedback on any of this, please reach out to me on my LinkedIn or on my email. Check out the blog that we have. Check out Cypienta for contextualization and correlation models, and I'd be happy to essentially hear your thoughts and essentially figure out how could we solve bigger problems in the next Blackhat for our partners and for SOC analysts like yourself. I appreciate you. Thank you very much, and looking forward to your questions. Take care.